So here I am. Hello, Mr. Camera. I got a laptop, and I've got a weigh scale, and I've got a little computer circuit here that is converting the duty cycle, the pulse width modulated waveform from here into a high power signal that can drive the Quadranoid, the Nitrous solenoid. So if I turn on, I'm just going to purge, so I'll turn on the gas and I'll just purge for a sec. So I'll just turn on the output for a sec and it'll spray the nitrous. Hopefully you can see. Right, it works, right? Whew. However, I'm going to close the door so I don't get all the nitrous in the house as I run these tests. And you'll just have to bear with me as I do that. So obviously it works, the system works. I'm going to set the frequency at 35 Hertz, which is the maximum frequency. And the first test I'm going to do is 30% duty cycle test. I'm going to do 30, then I'm going to do 60, and then I'll do 100, and just get a rough idea of how linear the flow rate is. So I'll zero the scale, and then I'll weigh this tank and see how much nitrous I use in a say a 20-second period or 15-second period. So it's 11.55 pounds as a starting point, and then we'll do 30%. Now, before I do that, I'm actually going to increase the pressure in the nitrous tank. It's a bit cold in here, and the normal operating pressure for nitrous should be in the 900-950 range. Right now, what does it say? It says it's 800, which is, you know, slightly cold room. So I use my compressed air. I don't have my system set up correctly yet to do this automatically, but all I do right now is I'll just increase the pressure in the tank, and you'll hear the air flowing in, and I'll increase it to 950. And once it's at 950, I'll run the test, and it'll drop during the test a little bit, but at least it gets it closer. Okay, so there's 950, and I will just purge this line. This is high pressure air, 3000 psi, and then I can release this. So now I've got the high pressure air. So nitrous tanks at 950, as I said, it'll drop during the test. I'll run the test for, let's see, 15 seconds. Alright, so I'll get ready to go, and then we'll hit the power for 15 seconds, and then we'll re-weigh the tank again. Okay, 3, 2, 1. Oh, I screwed it up. Okay, I'll take 1 second off there. 2, 3. Okay, so there we go. That's 15 seconds at 30% duty cycle. Let's see how much it weighs now. This is 10.71. Take it off and put it on one more time. Just triple check, make sure it's zeroing correctly. Slightly off, so let's zero it. .65. So let's see if it zeroes again. I'm getting quite a wide. Oh, I know what it is. I'm pulling it with the cable. That's why it's not quite accurate. Let me just relax it with a little less cable tension. So 10.8. Let's go 10.8. right? So it's dropped from 11.55 to 10.8. So it's consumed approximately 0.7 pounds of nitrous in 15 seconds. And you can calculate how much horsepower that is by running the math of 0.0008 pounds per horsepower per hour. So if I pull up per second, I'm sorry. So if I pull up a calculator, and I'll just run this math. So it's 10.8 minus 11.55. So it's 7.75 pounds in 15 seconds. So we'll divide by the 15 seconds, and we'll get to 0.05 pounds in a single second, and then we will divide that by 0.0008, and that says 62 horsepower. So that was my theory, is that this, even at a pulse width modulated condition, it was flowing quite a bit of power. You would think that these are 80 horsepower, that these are 20 horsepower jets. You would multiply by 4 to get 80 horsepower times 30%, you should get 25 horsepower. And it's saying it's flowing 60 horsepower worth of nitrous, which it's good to know that the linearity of this thing isn't great. So I can actually run this test with 100% flow, and I'll do it just for 10 seconds. And maybe I should just do it for a little less than that, but I'll do it for I'll do it for 10 seconds. And instead of modulating it, we'll go straight to full power and see what the flow is. So let me just double check that we're zeroing out here. The scale's, it's a heavier scale. I probably should use a higher resolution scale. Okay, so we're at 10.8 still. So what I'll do is I will go straight onto power for the nitrous for 10 seconds, and then we'll weigh it again. So let me grab the power lead here, and we'll go straight, boom. So no delays. So again, we'll count down, and then I'll hit the nitrous. So 3, 2, 1, 0. 10 seconds. Okay, and again, we'll weigh it. .54. That can't be right. Something's not right here. It says it's exactly the same weight. Again, it says exactly the same weight, 10.8. So I have a failed experiment here. Don't know why I did that. I think the problem is I've consumed all the nitrous in the tank. I'll just check again, but it looks like it's no longer flowing liquid, so I may have hit the bottom of the tank. I was playing with this quite a bit already, so that may be the issue. I've got a very low pressure on the tank all of a sudden as well. It's only showing, what's it showing from? It's only showing 650 pounds of pressure. So that type of dramatic drop in pressure, partly because the tank cooled off, but partly maybe because the nitrous is dead. Let me I didn't know what the empty tank is because I've added all these hardware to it, which increases the weight. So the tank emptied 7.5 pounds. I'm not sure all this other stuff weighs 3 more pounds, but maybe it does. So I'll put some more pressure in the tank and see what happens here. Oops, turn that off. Oh boy, it looks like the tank is close to empty. I'm having trouble consuming a lot of air just getting it up to pressure, which this tank's down to 1500 psi to get this up to 1000, so it's definitely almost empty. So there's 900 pounds of pressure in the tank, but that gives you an indication that we're empty. I do have more nitrous soft to refill this. Interesting. Okay, let me just hit the nitrous for a sec and see if we're getting any actual liquid out of it. No, we're not. So we're empty. So looks like I got one test in, and the test indicates that we're not getting much linearity. Kind of is what it is, but I'll run some more testing and see whether or not modulating the solenoid makes a huge amount of difference. It may be that I'll have to put smaller jets in it. So if I don't really want to hit 80 horsepower, I want to hit sort of in the 30 to 50 horsepower range typically. Maybe by running 15 horsepower jets for a total of 60, and then I can maybe get it down you know, to maybe half that setting on a very low pulse width modulated setting. So we'll have to see. So I've got a Nitrous Wizards, NOS Wizards solenoid here, and I realized that it's got an adjustable plunger, so you can take this cap off with this Allen head, and then you can stick a flathead screwdriver in there and you can actually change the depth of the plunger movement. So for higher frequencies, I'm trying to run 35 Hertz, what'll happen is it'll actually have to move up and down a lot less. So it should be able to be, what was happening in the past is I think with the high frequency as well as the rapid duty cycling, the plunger wasn't closing fully, wasn't opening fully, wasn't closing fully, so it was sort of floating half open. So now I've got the plunger a lot narrower and it's going to have way more control. So I should be able to go from about 20% to 80% and actually see differences for that whole range. So the first thing I'm going to do here is I'm going to run the nitrous full for 5 seconds and just see what the bottle is. So right now the bottle's at 15.6 pounds. It's full. It's actually 1 pound over full. And I'm going to run the nitrous I'll just start for 5 seconds and then we'll see what happens here. So 5 seconds of the nitrous going full. So let me just get my countdown timer and then we'll rock and roll. So let's go. I'll do the countdown in a second. 4, 3, 2, 1, 1. Oh, you know what? I didn't turn the nitrous bottle on. So let me just open the bottle up. And I realize I've also got to purge it. So let me just purge it for a sec. We'll watch it purge. Okay. So let's go. 3, 2, 1. No, I'll do it again. Sorry. 2, go. 3, 2, 4, 5, 6. So let's see where we are for bottle weight now. So I'm just going to hit, I got to zero the scale again. So 15.4 I'm going to write that down. So we start at 15.4. I'm going to run it for 10 seconds this time. And we'll see what it is after 10 seconds. Okay. So here we go. full 10-second blast. And let's see where we are. So we were at 15.4, and let's say if it zeros, almost, let's zero it exactly. And let's see where we are after 10 seconds. So 14.4, 14.48. So I can tell you right now, 1 pound of nitrous in 10 seconds is about 100 horsepower. So that shows you that even with that solenoid closed a lot, it's flowing a ton of power. Now that's at, that's about 750 psi of bottle pressure. So now what we're going to do is I'm going to set it up to actually run on a duty cycle. And I'm going to set it up at 50% duty cycle for 10 seconds, and we'll just see what happens on the nitrous flow. So I have my setup here, and we'll just do a quick test to make sure that my system is running. So this should be pulsing. You should hear it pulse. Hear it pulsing? And actually it's fallen down, so I'm going to move it back up on top of the box. Alright, there we go. So you can see it a little bit better. Okay, so let me do one more weigh scale thing so that we know exactly where we are. Tart. Zero it. So 14.6 still, 14.5. So let's go 10 seconds at 50%. 3, 2, 1, go. Okay. And then we are going to zero it and weigh it. So it's 0, and let's weigh it. So that's beautiful. You see it took half a pound of fuel in 10 seconds at 50%, which is, guess what? That's exactly what we want to see now, right? So it's around 14.15. Let me try measuring it one more time. This scale is not super accurate, so plus minus 0.1 pounds probably. So 14.2, 4.1. So at 50%, we're seeing a little under 50% of the flow. So let's go to 25%. And so we're now going to do 25% duty cycle, and let's just go. Let's just do it, and let's do it. Let's do it for 10 seconds again. Okay. So 1, 2, 3, 4, 5. So let's do it timing wise. So this is only 25% duty cycle. 2. Okay, and let's see where we are. So we'll go to zero it. That's beautiful. Okay, 14.0. So it's, you can see it's working beautifully now. The range is pretty good. We're down at 25% duty cycle. Yeah, so it's less than 0.2 of a pound. Okay, I'm hooked up with the push system now. So there's the carbon bottle, and here's the regulator gauge, and I've got everything opened up. So I don't know if you can see, but we're about 675 psi, and I'm going to just turn this regulator with the screwdriver here, and it should activate the solenoid. See, it's moved it up, and I'll turn it some more. See what it's doing? It's regulating it up. So where am I? I gotta make sure I don't go too high. I want to go to 900. So we're 800 something. So it's adjusting, you see, on its own. Okay, where am I? Just below 900. So this is the perfect regulator. It's basically going to
guarantee that I stay at 900 all the time. So maybe just a tiny bit more. Yeah, so what we've got now is, unlike most nitrous systems that use a bottle heater, what happens is the nitrous leaves the tank and it causes the bottle to get colder. So the nitrous is expanding a little bit as it's going into the line, and then the bottle just gets colder and colder and colder as it empties, and that causes the temperature to drop more and more and more. And then you end up in a situation where you've got a lot less bottle pressure after a little while.
Well, everything worked out actually. I got all this stuff. The only thing I actually had is this check valve, this one-way valve, got a little bit frozen after sticking this bottle in the freezer so I could transfer more nitrous to it. You have to cool this one down, and then the warm will flow to the cold bottle and fill it. And it stuck open a little bit, which was interesting. Anyway, I tapped it a few times and it seemed to seat. So I've run through the numbers again, and basically I did much longer pulls this time. So I did 30 seconds at full power instead of 10, and then I did like a minute total at 25% duty cycle. And you know, it worked out that I got 58 horsepower on the 15 horsepower jets, which is right. It should be 60, so it's at 58. It says I got 25 horsepower at 50%. Now remember, I'm having plus minus 0.1 pounds approximately to sort of plus minus 10% or worse accuracy on this type of measurement. And then it said I have 16 horsepower at 25%. So that's perfect linearity as far as I'm concerned. It makes me feel good. So I had the solenoid, as I said, the seat height dropped to the absolute minimum, and the smallest jets, and then I got within range. And it seems that if you open that seat height up too much, it flows a ton, and it seems to sort of overpower the jets, or at least the jets flow more than I'd like them to for a given setting. I mean, every nitrous company is a little different, and sometimes people want, you know, their nitrous jets and their kits to be a little more powerful for a given setting than their competitors. So who knows if NOS Wizards is in that game or not. But you know, I don't want any more than the real numbers, and I'm using that, you know, 0.8 pounds per 100 horsepower per 10 seconds, or 0.0008 pounds per horsepower per second as my benchmark. And I'm using computer control, and I'll have closed loop wideband oxygen sensor feedback